Yeah.
So those are my two anxieties. So when I say I don't know, or if I say I'm just guessing,
or people think,
where,
some people think, if we go, some people think this, or some people. So we just sort of
yeah,
going like.
because that's the other thing, is we don't really know that much of it. We know more than we knew 10 years ago, but we don't know that much about how the brain works. Mm-hmm. So there's a lot of people working on this problem. So what we don't know, I mean, what I don't know is huge, but what we as a species don't know is really, really big as well. So that's my little cautious.
Cool. So we promise not to publish anything as definitive proof that you say today.
Shaw says, yeah.
And or go away and drastically change our lives without any further research because of what you said today. On a whim. Cool.
Okay, so having said that, I love the plasticity question, because we did used to think that children's brains were unique. They are, in infant brains particularly. So when an infant is born, it has almost all the neurons it's going to have in its life. We used to say all, but now we've discovered that we now give birth to new neurons in our hippocampus and who knows where else. So all these things, even that we used to think were true, are not really true. But an infant has more neurons, for example, than any of us in this room. So you're born with a massive number of neurons. And then what happens, this is what I think is uniquely special about humans, is that we're born with so many of them, and they respond so well to the environment. So we take this, think of it as a big ball of clay, a bunch of neurons where everything is connected to everything, all the potential exists, and then you put it in an environment, and some of those neural connections are going to be useful, and the baby will keep those. And some of them will be dead ends, and they will fade away. And so what happens is you have growth of the pathways that are useful for the baby for getting along in the world, and you have death of the pathways that sort of connect parts of the brain that never actually need to talk to each other. And so doing that, the visual areas get connected nicely to the motor areas so that when the baby sees something, it learns how to reach out and pick it up. And that pathway gets reinforced every time the baby reaches out and picks something up, and that pathway becomes stronger and stronger and stronger. And so we used to think that something happened probably, well, sort of steady decrease during childhood, but that around puberty it kind of was all over. And we lost that plasticity. And partly that's true. So this is one of the arguments why people don't learn languages really well late in life, whereas children seem to pick them up just like that. Even the accents they can do, and later in life people struggle with that. Or people who've had stroke later in life don't recover the same way that infants who've had stroke. So in my postdoc I worked in a lab that studied children who'd had stroke in utero or had stroke during birth. And by the time they were 7, they were indistinguishable from their siblings mostly, unless you'd affected motor areas really badly, and then they would have motor problems, but really not so many cognitive problems. And not all of them, but many of them could recover really, really well from that. And you don't see that happening in 70-year-olds who have stroke. But what we know now is that your brain is, all of our brains are plastic, and they're always responding to our environment. It just sort of slows down a little bit, the rate at which it adjusts. But even if you learn a musical instrument that requires your two hands to communicate with each other, like piano, where you have two hands that need to be able to do something, you develop thicker connections between the two hands, the left and right hand areas of your brain, even if you learn later in life. So that changes. Kids who play video games have massive areas devoted to their thumbs in their brains. So you can imagine each part of your motor cortex does something. So yeah, they have very big thumb areas. And what you see is a lot of more recovery after stroke than we used to see, and some of that is good rehab and good treatment after rehab. And there was a recent case of something called split brain patient. And these are patients who have the left side of their brain disconnected from the right side of their brain. And normally the left side of your brain can talk and the right side of your brain can't. And this patient, 13 years after having the connection cut, as an adult, started to be able to talk out of the right side of her brain. So this whole thing that we lose, the plasticity slows down, our brains don't adapt as much, but we also don't try as much. I mean, if you've ever watched a 18-month-old try to interact with the world, they're continually touching and doing and moving and testing and everything. And so maybe it's partly that as adults we don't do that quite so much. But there's a lot of potential.